But today I'll talk a little bit about the Git hooks and Git Diff, and then try to understand what exactly are those two. So I'll talk a little bit about the introduction, talking about myself. Git hooks, what are they and how to use that? A small demo, but I try to do a demo. I haven't sacrificed any animals for the gods for the demonstration today. Hopefully everything will go okay. So let's see. Then I'll talk about Git Diff and how to do Diff in LabVIEW, and a small demo also about some tools I've been working on, and some tools that people can start using, and then give some feedback. So my name is Felipe Silva. I'm from Brazil. I live in Denmark for 5 years already. I'm currently working as a software architect at Siemens Garmesa, this company that does wind turbines around the globe. My role is a software architect that is hardware in the loop systems for the turbine control software. So the computer that's actually doing all the programming and doing all the control of the turbine, we do the counterpart, all the sensors and all the equipment in the turbine. We simulate and do this feedback, and they test the control softwares before deploying to the turbine. I'll show you a bit more about that afterwards. I'm working with LabVIEW since 2013. I'm CLA and also LabVIEW champion. Yeah. So this is a little bit about the work we do there. So this is an example of one of our we call today simulators. And in these simulators we have all the electrical I/O signals from the turbine connected to the control software, and then the other side we have the NI equipment with the digital input. We have the digital output, and that's the picture is showing the bottom here. We're just replacing the environment or the turbine part with our system with all the information that the environment would provide, like temperature and pressure and so on. We do that then in LabVIEW with the PXI system. More on that, if you want to know about that, we can talk later, of course. So, yeah. So talk about Git hooks. So what are Git hooks exactly? So as the name mentioned, hooks is some actions that are triggered in different steps when you're using Git. These actions then can trigger execute some scripts, and then these scripts can be a variety of languages. Actually, is depending on the OS, actually, not on Git itself. So the most common is Bash script, and Python, Ruby, and Perl, and many other scripting languages you can use for that. These hooks, they run on actions on both on clients, which is you, your machine, doing. There will be some actions that we'll do when we do, I'll show a little bit about the actions. And then when you push to the server, or to the remote, as Anna's mentioned before, the remote also can execute some hooks. For example, even fail your push because you have pushed something wrong. So most known actions in Git hooks are the one that we mostly people talk about and use for creating hooks is the pre-commit. So you're doing everything there and commit, then these hooks will be triggered, and then execute some actions, and then will return if the commit is going to proceed or not. So it's going to fail your commit because something is not right. So they have the commit message. This one is for checking your commit message. If you want to be compliant with something, then you want the commit message looks exactly like some pattern always then you use the commit message. Pre-push, also, as the name say, push and pre-push, then it runs something before you push to the server. And post, check out, and if you change branches, check out a file from another place, and then this hook will run afterwards. So if you want to load some dependencies or do something like that, this post checkout can be used. And there are a lot of other hooks: apply patch message, pre-apply patch, post-apply patch, pre-merge commit, post-merge, and they have a lot of them. Yeah. So where are they then? So in the Git folder, we have this, your repository, we have this small folder called .git. It's usually hidden. If you want to see that in Windows or Linux, you need to show hidden files. Then you, inside the Git, you have the whole Git structure with your files, objects, trees, and so on, everything that Git uses to do the Git stuff. And then if you open the folder hooks, then you have all the available hooks that you can use for executing these tasks. Git by itself already provides these files. It's called .sample, which is exactly if you remove the .sample, they will already be enabled as a hook. You can open it and see what it does. What it does, it has some example actions that you can start using and can do something from there already. So I think by default, most of them are written in Bash script. So if you know a little bit about Bash script, then you can understand what's happening. Why then bother about these Git hooks? You can use the Git hooks for quality of your code, prevent non-compliant code. Some code that's something that you don't want to be committed, and you just say, no, this is not allowed. In a company with a team, it's important for standardization in the code, so everyone aligns the same idea of how you wrote the code. Then you put in a hook, and then everyone will try will be forced somehow. Of course, you can always circumvent Git, but you can do that. You can try to do that. And then linting, if you have XML, JSON, other configuration files, for example, there are a lot of linting solutions that can fix your structure of your code. It would always look nice. So when you're committing, everyone committing helps also reducing a lot of noise in Git, because every space you put in commit in a text file, for example, the Git will show that. But if everyone is aligning and the indentation is always the same and everything is good, then this noise will go away. Validation, of course, if you work with an example of the XML files and you forgot to close a tag in XML and try to commit that, then this is already in the server, and then someone pushes and then pulls this code and it's wrong and it's broken, and that would be a mess. So you can validate this configuration before you're committing or before you're pushing and say, okay, this is wrong XML, I have to fix that, and so on. The amount of examples is really big. If you can look at the web, people have a lot of ways to use the hooks. One I read recently, a company just put some hooks to prevent people from committing secrets or passwords. People just do some testing, put some passwords in the code, and commit, and then goes to the server, and then someone finds, and then the damage is done. So there is some hooks that can look the code and see that, this looks like a token or something like that. Forbid to commit or to push. So I like the idea. Can I use it? Yes. Yes. Of course, you have 3 options. You can, as I mentioned, go to the Git hooks folder, as inside the .git folder. Go there, get the scripts. I did it. Done. You have your Git hooks implemented, and everything should work after doing some testing, of course. Yeah. Just one thing I mentioned, I have been in all of those 3 places, so I tested all these 3. I started with the first one, and I said, I don't think that will be not scalable. Then I went to the second one, which is multi hooks or multi-language framework for Git hooks. So we can go to this. It's a really famous one. It's called Precommit. It's made in Python, but you can use for any language. And when I saw multi-language, I said, LabVIEW fits there, multi-language, right? And then I went there and created a wrapper for Precommit. It's Python, but it's what's called in LabVIEW behind the scenes. And it works. It's tested my idea. I used for some time, but was quite slow because it's on every action needed to call LabVIEW, and that was really slow to do this call using GCLI that I was using calling LabVIEW, doing the next action calling LabVIEW, loading all the files, and then every time it was loading the files many times. That's LabVIEW doesn't like that, so I thought maybe I can do that. Maybe I can do the framework myself. Yeah, and then after a long time, I think it took more than almost a year to develop this in my free time. So it was 1 hour here, 1 hour there, so it was not that easy. But I created this framework in LabVIEW, so it's available for downloading. Not many downloads there. I hope after this presentation we'll have more. But it does almost the same thing. It was inspired by this Precommit in Python, and it does the same thing. So it has support for 2 hooks today. So Precommit and commit messages. So those are the ones that I most use, and they're the ones that I chose to start supporting. Of course, we are open to implement many others if people feel like they need other types. So let's go with the small example on using your Git hooks or using your Git hooks in your workflow, for example. So you install the VIP package there with the Git hooks framework. You created your configuration. This tells exactly what hooks you want to run when the precommit executes. There's more information on the README if you want to know about this. I won't go with this path today. Then you are editing your code. You're dragging blocks around there. So that's what my wife says when she looks me at working. She's like, "What are you doing? Just dragging blocks?" It must be fun to earn money doing that. So I said, "Yeah, it's quite fun." So then I was just dragging around, and I said, "Okay, now I'm good to commit." Then I go to the terminal. I use mainly CLI to do my Git stuff, and I do Git add and do a Git commit. Bang! The Git hooks start running, and then it checks many things. Broken PI code? No, the PI is good. We have created a small formatter to do some arranging windows and some stuff that it's always good to do. Separate compile code and control names, errors, and so on. So it did fix this everything. PI description. Oh, I forgot to put the description. Class mutation history. Oh, so that was not a class, so it skipped that one. Checking missing items. Sometimes library projects. If you forgot you delete something and forgot to remove the project, that'll pop up there. Then file was modified. Let's put a Git status and look there. Let's say that, well, two files, the same one. So I have the staged one, and then I have the red one, which is modified. So what's happening? So that's the Git different states that we have for the file. So that's the first caveat that we have in the Git hooks. You really need to know exactly how the states work in Git. Otherwise, you get things confused and you mess up. So it's a good thing that you first understand really what the states are, and the stage, the committed, and so on. So until you get what is happening. So what happened actually is the hook changed the files, or the hooks changed the file that was being examined, but it didn't stage that file. So this red one is in the work tree that you have there. And if you open it, it's the file that's actually fixed by the hook, but it's not staged yet. So this means that the hook doesn't do stuff for you without you checking before if everything is okay. So then you can open it and see, okay, the hook fixed something, changed something, but yeah, okay, the hook was wrong, for example. Yeah. Then you can, of course, decline it and then try to close again. There's some question there. Okay.
Yeah, it's what is happening if broken code, but then you can ignore the hook.
Yeah, exactly. Yeah, you can use the no verify option that you can skip the hooks. But that's if you do in command line. I don't think there is options. I haven't seen in GUIs this option to skip. Maybe some of them have.
Maybe. Oh yeah.
Yeah. Okay. But what I do, I agreed with the hook. I added them again, so I go there, git add again, as I did in the first step, git add, and then git commit again, and then, oh, everything passed. Then it goes to the second screen where you have to do a commit message. Done. You nailed. It's everything good.
So you have set it up, so first commit, and then it comes and asks for a message afterwards.
Yeah, then if it passes everything, then you just go to the commit message. Then you just do whatever you ever do.
Yeah.
So. Then say, annoying, right? So every time you just go there, run everything, something wrong, add again, check, commit again. In Danish we say, nej tak. I think I don't want to do that. That's quite annoying. But maybe there's a solution. Yeah. First, let's talk about the hooks. When you install the Git hooks, you have actually two libraries. One is called the developer hooks and the Git hooks. The Git hooks is only the framework. It's only the engine that is running with the Git. And together with this is installed another package, which is developer hooks, which is VI with a template VI that the Git hooks call to execute whatever you want. So the moment you install the developer hooks, you get in the user menu on the new menu, you open there and then go dev hooks and then have hook templates. You create a new VI from this template, and then you have this template, which is a class input with a lot of inputs there that you have available, and an arrow out. So if you want to develop your own hooks, what you can do is just implement this VI and save to a specific place. There's explaining everything in the README, so you can go there and take a look. But essentially then, all this information will be available at the runtime to your action. Then you can use that for doing VI scripting or whatever you want to do, delete files, move files, do whatever you want. And then the arrow you just have here is, if it has an error, the hook will fail. If it doesn't have an error, the hook will not fail. Simple as that. So it's a way that you can create your own hooks. if you are not satisfied with the hooks that are already provided by the library, we have already a set of hooks, so you can get that set. Then you have we call the developer assistant. That's what saves the day now, because it's what helps me keep using Git hooks. Otherwise, I would have given up on that for a long time ago. What is the Dev Assistant? So it's a standalone VI. You have, when you install it, it's just runs and has a file system watcher with the Dev Assistant. So as you see the picture in the bottom here with the example, we have the Git hooks in the one side and the Dev Assistant in the other side. Both of them use the hooks. So what happens then? When the developer system detects a change in the disk, it runs the hooks, the same ones that you use in the Git hooks for you during the save. So what happens is then when you're going to do a Git hook, you're not 100%, it's more than 90% guaranteed that you're going to pass because the same thing is doing, instead of doing it later, you just do it before actually the hook runs. So it's as is the same action. I expect that if you did before, when you're doing the hooks, then it's nothing happening. There's some nice features that I added over time. Is supports keyboard shortcuts, so you can do some keyboard shortcuts and call some hooks from that. Supports Git timeline, so you can, when you find a VI, you can select the VI, then show the timeline of this Git. So shows all the commits related to this VI itself. If you want, then of course you can click one of these commits and then compare using LabVIEW compare, and compare these two VIs or two commits easily, or more easily than trying to copy the VI to a place in your disk. Yeah, I think I can try to show a little bit about the developer assistant and the Git hooks. So I think I have my VM here. So let's open with maybe this project is not a good one to open. Let's not go to this one. Let's open this one. So you see that it's already did some formattation. Well, this format the VI. Let's try to do something here. I don't like that. I put like that. And I went here and put something like that, and I say, I don't want that. Why would I put that like that? And then of course, and then I save it, and you see it says that it ran here, it fixed the VI, it changed the terminals and so on, so it already did that for you. Checked again this guy here, and also saying that the description is missing. So I could go there and say, now the description is something about the issue. This is nice. And I save again, then it's
Yeah, one of the things you're also doing is that you are moving the block diagram and you're moving the front diagram onto the main screen
yeah,
at the top corner. So
Yeah.
even if you have multiple developers having different screen sizes, it will always be
yes,
on that main screen
Oh,
Yeah.
at the same place. So if I check Philippe's code out, the VI will be placed the same place.
it's kind of addicting. Yeah, when I start using this and when it's not running, then I say, why is not arranging my VI already? So it's crazy. Yeah. So let's just get here, for example, here. If I open this one, okay, then I can get here this VI here. This is another code I'll show a little bit later, but I can just open here. I can go to the Git server. In this case, because it's gitlab.com, so it supports those. If it is a custom URL that's not working, but then it's going to be disabled. But I can just compare here. And it's just comparing both. It's just launching LV compare. So it's from now on, this is not part of the Git hooks anymore. So then you can see the changes and so on. Yeah, and puts this label here so you know exactly which one is the one that it's the old one, for example, and who did the commit and so on. So it's quite handy for looking at the history for that specific VI. And this guy here works on project basis, so you need to have a LabVIEW project running. So I can go here and then go here. So I get. Am I going to pass? Maybe. Let's see. I think it's. I don't think it likes the project open there. There's a conflict there. Let's see. Yeah. So as I mentioned, it passes on all and I can just go here and then do my commit. Oh, keyboards. Keyboard differences, yes. And then it's going to run my commit message. I'm checking my commit message too and checks if everything is okay. So in this case here showed two different hooks, one that's run before the commit, another one that runs after the commit. But not after the commit being validated or fixed, but then validation of the commit message. So it's here I already checked because I already did in the developer system, so the Git hooks were just saying, okay, that's everything okay. This is just to make sure that everything's okay. You had a hand somewhere, I see.
So, Felipe, I see you're using conventional commits.
Yes.
Could you speak a little bit about that?
Yeah, the conventional commits. Yeah, it's a non-commit convention message that it is implemented in many places, and it's nice because there's a lot of tools that use the same format, so you can have a lot of tools that can use these messages and do whatever you want, create change logs, some other parsing that you can do. But if you use the conventional commits, then you don't need to invent a new pattern, right? You can just use something that's already there, available there, and have a lot of parsers in Python and Node and C and so on. So we have a lot of things that are already done for that. So it's if you don't have a standard message, suggest you check the conventional commits. So it's a good one. And then, for example, this validation that I do, I actually stole a regular expression from somewhere that's already doing this same type of validation. So it's handy because I can just reuse many of these things that already are available out there, open source. Yeah. So as this one and the other code I have, all of them are open source. So you can just go check and see the code and hopefully contribute. That's the best part. And contribute doesn't mean actually creating or making coding. Contributing also makes creating bug fixes, bug fixing on bug issues, saying, oh, I found a bug somewhere. Or this could be improved because it doesn't look nice or something like that. Doesn't mean that I'll do that or someone will do that, but it's nice that someone is actually giving some feedback.
And just to go back, when I install the VI package you have on VIPM,
yeah,
then I get like the framework how to do it and some examples.
Yeah.
And then implement the own way we want to do it in an organization, and then create a new VI package for that, and then send it to your colleagues and say, install this one here. Is that the way to do it?
Yeah.
Or, okay, yeah.
Yeah, of course, then you use the Git hooks as a dependency, of course, then you need to install it, yes.
Yeah. No, yeah, okay, yes. That one you need to install, but that is a dependency. Yeah,
exactly.
But you need to install it on all machines. It's not something that installed it on the server. Yeah, it's on all machines.
And then installing Git hooks, I'm not going through this today, but this tool I do, it has already some. If you go here, go G, CLI, Git. Oops. So it has a, you have a nice help there saying that install, then install the Git hooks. So it's actually doing this scripting VI that I showed before. It's going to replace that VI with one that runs this guy. Uninstall, we just remove that away. Run is actually this action that we see now that's just running. So, and help is just running this string. So it's really straightforward to do. So it's you just go to your repo, git install, GCLI, git hooks install, and that's it. Then you just do the configuration. I think most of the README is explaining some of that. If it's not, just ask me. Then I'll just amend the README because it's probably I did from my head at the time, and that's how it is. So. Yeah, and then let's go to the second part then, talking about the Git Diff. A small sneak peek was this developer system that you can do a diff there using the LV compare, so it's handy already using that one. So what is Git Diff? So Git Diff this is definition from the Git Diff command. So it's show changes between commits and working tree, and many other use cases. So when to use, so whenever you have something that you want to compare between two versions of the same VI in Git, it's a good idea to use Git and say, what have I changed there? Or what did that guy change there? And so on. So sometimes it's not nice because people find someone to blame. So there's actually a command in Git called git blame. If you look at it, it's exactly for that. So you can see who changed the line in Git. There is a difference between lone wolf developers. That this guy that is just sitting alone in his corner, coding all day. He knows everything about his code. He usually doesn't need to use this because he did all by himself. But even those, they forget after 1-2 years, you get back to the project and say, I did that. Yeah, that's also maybe good for this type of developer. The other side, you have the teams, working with teams, and that's really, really important because a lot of people changing the code all the time. I think in our team we have 6 to 8 developers and people just changing code everywhere. And if you don't have a way to look at Git, it's the differences, then it's complicated. The main example is the merge request, as we call for those using GitLab. or pull requests. That's for GitHub. So then we have this pull request, and we say, this changes. I want you to do a review and or take a look. Not maybe a review, just take a look and see if that makes sense. And you say, what you people just do? Open the VI and say, yeah, looks good, but what was changed there? So that's sometimes you say look good, and then hopefully that doesn't break anything, and then I approve, or it looks good, everything's okay. So it's that's usually what most people do, just review the code by just looking at the current or description of the commits or description of the feature, and just go and look at the code and see. It's doable most of the times. It's the small code bases, but big code bases, I think it becomes a bit more complicated. So I'll talk about the LV compare. So this is the way to do comparison between two VIs in LabVIEW. It's a native tool in part of LabVIEW installation. Has a lot of good improvements over the last years. It's really good. It's got really better than pre to 2020. It was not really nice to, and the differences were not really good to show. And then from 2022 Q3, if I'm not mistaken, plus, then it's available in all editions. Before it was only available in the LabVIEW Professional. Then right now it says you install LabVIEW, then you have it, even in the community edition. From 2025 Q1, I think Q3, then we now have single page HTML reports, and that's those provide all these reports with all the changes with only one page. Before you had like an XML, then you need to transform the XML to create an HTML. It was not nice. And I committed. I have put some links here about the NI part, and I committed to continue to improve this tool. And you can see in all the release notes, they always updating something in the LV compare now. So it's good. So how do we do that? So first you have to open the two VIs you want. You go to Tools, Compare VIs, and then select one VI, select the other VI, and then check the comparison report, the same as I was showing before. You can also go to the installation directory. So this is dependent on the business, I think. So we can go to the shared, National Instruments shared, and the LV compare. Then you have the application there, which is a command line on the application. So you can interact with this application, and then you can launch it and do the comparisons with the command line. And I'm pretty sure the top one is also just a user interface for the command line, which calls that in the background. So it's the same thing. Let's talk about this. From version control, as we see, it's not really practical. You need to have both VIs in memory. So the UI version that we showed, the first one. So you need to open both two VIs. This means that you will need to open the VI that you want to compare and download the other one in another place. Probably you have to open another project because that will have a conflict if you try to open both at the same time. So then you need to load them. The application uses command line and also needs both VIs to be in disk. I think the application part is a bit smarter about the conflicts and so on, so it's not going to have a problem. And then I just put a normal use case. You copy the previous version from GitLab, download it, put in the download folder, run LV compare with both of them, the new one. Yeah. I say it works, but it's not really nice because you have a lot of broken wires because the other VI you downloaded it doesn't have the whole hierarchy. does have the class, the library that was on there, all the colors that was over there. So it works, but it's not a really nice workflow. If you use Git, it has another command called Diff. That one can do something and then call LV-compare behind the scenes, check out this temporary version that you want instead of you doing the downloads manually and so on. So it knows how to do things, and but it's not compatible with the LV-compare way. But Sam Taggart did a scripting that does that. So it's, if you want to use this way, you just go to his blog, download the repo, install it. Then you don't need to do anything else. This download stuff you need to do. So the way to do is it's called the command git diff tool. So this tool will install this script from Sam. You install a lot of information telling to call LV-compare behind the scenes when you using VIs. So get git diff tool main, and then 3 dots branch, and then in this case I just want to see VIs and just put VI at the end. Then it's going to get all the changes between the 2 branches, only VIs, and give to LV-compare. So it's way better than we had before. So I think it's a win. So then we have this small thing about the 3 dots and 3 dots, but I don't think it's for today. Maybe one other day we can dive into these small things in Git.
Yeah.
But it's usually I use the 3 dots because I want to see what I changed in the branch, not the 2 dots. The 2 dots is everything that's different between 2, essentially. So that'll show much more things than you want to see. So. But doing that in the command line will show this small screen there that I have there. In this case, I have 2 VIs, 2 that were different, and then it's asking for me to compare them. And then it has yes or no, then you just go for the list, and that's going to launch LV-compare for each of them. So you can do this batch of changes one by one. But alternatives, what you have a tool to create previews of the VIs and also Diff using the 2025 single HTML report. Yeah, that's another thing I was working on, and that's supporting only LabVIEW 2025 because we have this HTML single page report. And this code generates full previews of projects. So you have a folder with a lot of VIs, and this guy just scans the folder and runs and generates HTML previews of all of these VIs. The HTML part is part of this G preview, LabVIEW from LabVIEW, and he's this guy based on US, and he did this in his HTML, is doing LabVIEW scripting, parsing the VI. I contributed with some of these the features also in this code, and from there he created a VS Code extension that you can actually see the previews of VIs in VS Code. So you can actually navigate in VS Code and click in a code there and see the VI already from there. And what I did was just on top of that create a preview from all the projects and show that in the tree. So another good thing, generates LV-compare Diff reports with no broken wires. So that's another win, and I'll show a little bit about that. And VIs can, that's something that it's being working on, and then you can navigate within VI, so you can click on the VIs and can navigate within the same project. So it's something really interesting that is being baked right now, and I think I can show a little bit about that now. Yeah. So this is an example of the page. So it's full HTML, so you can open anywhere, including in your mobile. So, and then has the tree of your project. And there you have the example of the block diagram. You can navigate through the case structures. You can click on some of the eyes that are part of the project, so it's something interesting. And then you have this button there when you're using the Diff mode, not only the preview mode, the Diff mode. When you click that button, then you have only the changes or the Diff changes that you did. And then you have the comparison report that was created from LV compare already before, and then shows the changes that were before. So in this case, for example, the first one is telling, Git is telling it is modified, but LV compare says no changes. So it's probably some metadata in the VI that was definitely not important. So the other one that has an R, it's renamed. In this case, there we're saying that the VI was renamed. No change, but was renamed. So it's just saying R. The top is saying that was renamed from one to the other one. But that's why Git told that was renamed. So it was not something like you did or reinventing stuff. So it's Git telling that was renamed, and that's what we do. So then I have a small demo. This is the command line interface. It's called GCLI Diff Preview. And here you can have a lot of different options that you can do. You can specify which folder you want and where you want, which branch, from which branch to which branch, and so on. If you can decide to include the previews from all files, or you just want to see the diffs. That's also an option. And then you can also remove some of this noise from LV compare. That if you moved a centimeter, a pixel there, something, that'll show in the LabVIEW compare. But you don't want that, then you can just go there and remove the cosmetics and no front panel position, and you have that clear. So let's show about this a little bit about this one. I think I had the command is quite big, so I'm cheating here. Yeah. And this has I implemented a nice cache feature, so it doesn't do the preview again if the preview was already done. Also, the diff doesn't do again if it was already done. So in this case now it's generating a preview of the files. It's saying that it requires 132 files to create previews. It might take us some time. It depends on how much we have there. Let's hope that doesn't take that long. I don't think it does. That's it. I think I have something already done. Yeah, okay. I think I have done something in the past. Yeah. So this is my project. I think this is for the Git hooks. So you can see here that you have the VI. You can go to the front panel, the block diagram, and go to the info. And here you have like the description and so on. So it doesn't have many things. And then you can go navigate through all the VIs that you have in the project. So, and some of them, as I mentioned, so you can actually do this change between, and then you can just go in, and some of them you can click and go to another VI. Was it done? Okay. Is it, okay, check. Yeah, I think my Diff part is not fully working, so I might need to take a look at that. But essentially is that. So you can actually go there and take a look and how things work. Let's see. Good question. Yeah, I think I haven't sacrificed properly the.
Probably.
Yeah.
I have just a small comment. You mentioned tool from Sam Taggart. He's calling the absolute easiest way to install Git compare and Git merge in LabVIEW. It should be said that since LabVIEW 2024, you can also just from your normal Git client, if you're using such one, you can just type in the LabVIEW compare and use that one. You couldn't before because LabVIEW couldn't open two VIs with the same name, and Git is saying it's just two different locations, but it's same name, and therefore it was first Stefan Lemmens from Belgium, and then later Sam was taking over, made this wrapper, so they were changing the names. But today you can actually just use the normal way of doing it, calling the LV compare with a normal hook, so you don't need it, but it's very easy, just 2 clicks install and then it's working. So it's still maybe a little easier than type it in, but it's close to the same.
Yeah. Yeah, but that's I think I was. Yeah, so it's so the clicking is working.
It's also okay if you don't have more. So much time you don't have. So
that's okay. I think I can. I think we have I have a demo on my website on the repo. If you go there, you can take a look.
Yeah, and some of it is generated by LabVIEW, and some of it is this one here. This one here is generated by you. Because we is asking about this HTML report. Is that generated directly by LabVIEw or from your tool?
No, LabVIEW. Okay. It's calling LabVIEW compare.
Okay, so that one is you can just call it from LabVIEw and then okay.
You can generate this report from LabVIEw.
Okay.
Yeah, so I think that's on the slide there. So I think it's because that. Yeah. So this one.
Yeah. Okay. Yes.
Yeah.
Yes.
For some reason my code is not getting the changes there. I don't know why.
Okay. Any more questions?
Let's wait something here.
Yeah, I have a basic question about the flow. The file, LabVIEW project file, does that never cause a problem in merging? Because whenever you open a LabVIEW project, this is going to be changed. And if somebody else is working on the same project, and later you want to merge these two, they may have been working on different files, but for certain, the LabVIEW project file is going to be changed. So does it work seamlessly? Or
what I'm at least doing is it's right, especially with IP address. If you have some of that, it's changing. But do not commit it unless you have changed something important. So you shouldn't just say I commit everything. You should say okay, the project file maybe it's changed, but you haven't changed anything. Anything in it, it's only like the IP address or something like that are changed, and then do not commit it and push it to the master.
I think the main problem is the dependencies on the project, and that was removed in 2026, I guess. Was it? I think the new version of LabVIEW removed that part of the project, so it doesn't save that anymore. So a lot of these problems will go away.
Yeah, that's right. Yeah, the dependencies are removed in the newer version.
But it was Q3 2025.
Okay, good.
I was so happy.
Jesper, you have a question?
Yeah, so when can we, in the 2026 Q1, supports web front panel objects? So when will we see this integrated directly into a LabVIEW VI? this HTML report?
I don't know.
Just an extension for your tool.
Yeah. Okay. But right now I got the project that was actually running with the diffs. So this was the previous project that I was, because that version that I was running didn't have the changes.
Okay.
And the demo changes was a different one. So here's the same project that I was shown before, and it has these marks on the diffs. And if you go to the show diff only, then it's going to show the changes that Git told was a change. So for example, this one's deleted. It has a big cross here saying it was deleted. And this one was modified, and I go to the diff and say that the VI version was changed. Yeah. So that's they're adding this extra tab here on the bottom with the diff report. That's the difference now. So.
But to sum up this, it's better in the new one. I wasn't so aware I have done so much in the new one. And then also be aware of not committing if you haven't changed anything.
But project files are a little better in committing, basically because it's a text file. It's not a binary file like the VIs. Yeah. So Git can do the merge because it's still just XML behind the scenes.
Yeah.
Yeah. But you don't have to do it manually.
No.
No. Okay.
Yeah.
But you say that you should not commit the project file. But if you have
if you have changed something, but if you just open it and the dependencies are changed, and you close it and save it, maybe then when you commit, then you should look at the files that are changed, and then at least what I'm doing is saying I have not changed anything to a project. It's maybe only if there is an auto-populating folder, for example, in that is auto-populated, then I say it's not the project is changed because the auto-populated folder is changed, but I haven't done any changes. Next time a person will open it up, they will get the same automatically. Therefore, I will not commit that change.
But if you add a VI, you have to commit.
Yeah, then you have to say
and if the other person also added another VI, then you are having a project file which has to be merged.
Yeah.
And my question is, does this work seamlessly?
Then we'll come back to maybe the organization on how you do your application, because having two developers working on the same project is a bad idea. So you have to, and that's some of the things I might be talking about later on.
It's create a project by sections of code. Yeah, it might be better than create a big project for the whole code.
That's an important message
to
add.
But I think actually it is in the next year. If there is no more, we have said a long time here, maybe we should take 10 minutes and then continue with Carsten.
Yeah.
Because it is some of this here.
And it's not just a LabVIEW thing, it's any language.
Yeah.
People think it's just a LabVIEw thing.
No.